Before the Tyrannosaurus rex terrorized ancient forests, before the Brachiosaurus shook the ground with thunderous footsteps, there was another world. A world emerging from the ashes of Earth's greatest catastrophe. 252 million years ago, 90% of all life perished in the Permian extinction. What survived would reshape our planet forever. This is the Triassic Period, the dawn of the age of reptiles, the birthplace of dinosaurs, the proving ground for evolution's most audacious experiments. Here, bizarre creatures tested body plans never seen before or since. Some would fail spectacularly. Others would spawn lineages lasting hundreds of millions of years. Tonight, we journey to this alien Earth, where the rules of survival were being written for the very first time. The World Reborn. The Mesozoic era stretches across 156 million years of Earth's history, from 252 to 66 million years ago. It encompasses three distinct periods: the Triassic, Jurassic, and Cretaceous. But our story begins at the beginning, in the Triassic, when life itself hung by a thread. The Permian Triassic extinction event had just concluded, the most devastating mass die-off in planetary history. Volcanic eruptions in Siberia pumped toxic gases into the atmosphere for millennia. Oceans acidified and became oxygen-depleted dead zones. Global temperatures soared to lethal levels. The few survivors inherited a wasteland. Yet from this devastation came opportunity. Ecological niches lay empty, waiting for new occupants. Evolution accelerated, experimenting with radical new designs. The Triassic period, spanning 252 to 201 million years ago, became nature's laboratory. Here, the first true dinosaurs emerged, alongside flying pterosaurs and marine reptiles that would dominate oceans for eons. The supercontinent Pangaea dominated geography, a massive landmass stretching from pole to pole. Its interior was scorching desert, its coasts humid and lush. This was the stage upon which evolution's greatest drama would unfold. The first dinosaurs. In what is now northwestern Argentina, 231 million years ago, something revolutionary was happening. A small creature, barely 3 feet long, scurried through fern-covered undergrowth on 2 legs. This was Eoraptor, and it represented the future. Eoraptor linensis is one of the earliest known dinosaurs, a member of the Saurischian lineage. Discovered in 1993, its nearly complete skeleton revealed astonishing details about dinosaur origins. Weighing just 22 pounds, Eoraptor was no giant, but its anatomy was revolutionary. It walked upright on powerful hind legs, freeing its forelimbs for grasping and manipulation. 3 long clawed fingers tipped each hand, perfect for seizing prey or stripping vegetation. Its teeth tell a fascinating story. Jagged, curved upper teeth like a carnivore's, but leaf-shaped lower teeth resembling herbivore dentition. Eoraptor was an omnivore, eating whatever it could catch or find. This dietary flexibility proved crucial for survival in the unpredictable Triassic environment. When prey was scarce, plants sufficed. When opportunities arose, meat was taken. Eoraptor's relatively long hind limbs suggest it was a capable runner, pursuing insects and small vertebrates across open ground. Evidence suggests Eoraptor may have formed small social groups for hunting or protection. While direct fossil evidence of parental care is limited, later dinosaurs clearly exhibited such behaviors. The evolutionary foundations were likely present even in these earliest species. Eoraptor's significance cannot be overstated. This humble creature stood at the base of a family tree that would eventually produce the largest land animals ever to exist. Every dinosaur that followed, from Stegosaurus to Velociraptor to Argentinosaurus, descended from ancestors very much like Eoraptor. Evolutionary Experiments. The Triassic period was evolution's most creative phase, producing body plans that defy modern imagination. Consider Longosquama insignis, a small reptile from 220 million years ago that looked like nothing else before or since. Measuring just 8 inches long, Longosquama possessed elongated feather-like structures extending from its back. These weren't true feathers as birds possess, but something unique, possibly modified scales or an entirely novel evolutionary innovation. Their function remains debated. They were unsuitable for flight or temperature regulation. Display seems the most likely explanation. Imagine this tiny creature in the forests of ancient Kazakhstan, its back adorned with spectacular plumes. Perhaps males displayed these structures to attract mates or intimidate rivals. Whatever their purpose, Longosquama represents evolution testing ideas that would later be refined or abandoned entirely. Even stranger was Eoraptor, a gliding reptile from Kyrgyzstan's mid-Triassic forests. Unlike modern flying squirrels or sugar gliders, Eoraptor attached its wing membranes to elongated hind limbs rather than forelimbs. This created a delta-shaped wing configuration unique in vertebrate history. At 10 to 12 inches long, Eoraptor launched itself from tree branches, gliding effortlessly through the canopy. Its tail could bend to create drag, allowing controlled descents and precise landings. This bizarre body plan worked. Eoraptor thrived for millions of years before vanishing without descendants. These evolutionary experiments demonstrate the Triasic's creative chaos. With so many ecological niches available, natural selection explored countless possibilities. Most failed, but the successful innovations would reshape life on Earth forever. Hunters of the Triassic. As plant life recovered and spread, herbivores multiplied, and predators inevitably followed. Coelophysis emerged around 210 million years ago as one of the Triasic's most successful carnivorous dinosaurs. Coelophysis burrowing is known from numerous complete skeletons, providing unprecedented insight into early dinosaur biology. Measuring up to 10 feet long and standing over 3 feet at the hip, Coelophysis was built for speed. Hollow bones reduced weight without sacrificing strength, a design later perfected by birds. Its narrow skull, approximately 11 inches long, housed forward-facing eyes providing stereoscopic vision. This depth perception was crucial for judging distances when pursuing prey. Coelophysis likely reached sexual maturity between ages 2 and 3, reproducing quickly to maintain population numbers. Evidence suggests Coelophysis possessed a simple air sac system, an evolutionary precursor to the highly efficient respiratory systems of modern birds. This would have provided enhanced oxygen delivery during high-speed chases, giving Coelophysis an edge over competitors. These dinosaurs primarily hunted smaller animals, lizards, early mammals, insects, but may have cooperated to bring down larger prey. Fossil evidence is inconclusive regarding pack hunting behavior, but the possibility remains intriguing. More disturbing is evidence of occasional cannibalism, with juvenile Coelophysis remains found in adult stomach cavities. Whether this represents opportunistic scavenging or active predation on young remains unknown. In a harsh Triassic environment, survival sometimes demanded desperate measures. Coelophysis exemplifies how predators evolved rapidly in response to new opportunities created by the Triassic recovery. Conquest of the Skies. While dinosaurs claimed the land, another group of reptiles took to the air. Pterosaurs appeared in the late Triassic, representing the first vertebrates to achieve powered flight. Eudimorphodon was among the earliest and most successful. Living along European coastlines 210 million years ago, Eudimorphodon measured just over 3 feet in length and weighed no more than 22 pounds. Its wing structure was revolutionary. A membrane stretched from an enormously elongated fourth finger to the body and hind limbs. A diamond-shaped appendage on its tail provided steering control during flight. Eudimorphodon's skull housed 110 densely packed teeth in a remarkably small jaw. This dental arrangement was perfectly adapted for catching fish, its primary food source. Preserved fish remains and fossilized stomach contents confirm this piscivorous diet. Imagine Eudimorphodon soaring over Triassic seas, scanning the water's surface for movement. Upon spotting prey, it would dive, snatching fish with precision before returning to coastal cliffs. While likely solitary hunters, some individuals may have gathered at rich feeding grounds or nesting sites. Eudimorphodon's success demonstrated that the skies were now open for colonization. Its descendants would eventually include pterosaurs with wingspans exceeding 30 feet, dominating aerial niches for over 150 million years. The Great Survivors. Not all Triassic creatures were newcomers. Some were holdovers from the Permian period. Lystrosaurus represents one of evolution's greatest survival stories, a creature that endured Earth's worst catastrophe and thrived afterward. Lystrosaurus evolved around 270 million years ago before the Permian extinction. Dog-sized and resembling a cross between a pig and a lizard, it was a therapsid, a mammal-like reptile. Ranging from 2 to 8 feet long and weighing around 200 pounds, Lystrosaurus was a specialized herbivore. It lacked normal teeth, but possessed tusks for digging roots and a horny beak for shearing vegetation. A secondary palate allowed simultaneous breathing and chewing, while powerful jaw muscles ground plant material efficiently. Most remarkably, Lystrosaurus was a burrower, excavating underground shelters to escape environmental extremes. This burrowing behavior proved crucial during the Permian extinction. As surface conditions became lethal, Lystrosaurus retreated underground, waiting out the catastrophe. Its barrel chest could extract oxygen from dust-choked air, another critical adaptation. When conditions improved, Lystrosaurus emerged to inherit a world with few competitors. For millions of years after the extinction, Lystrosaurus dominated terrestrial ecosystems. Fossil evidence shows it comprised up to 95% of land vertebrates in some regions. This incredible success demonstrates that sometimes survival, not innovation, is evolution's greatest achievement. The apex predators. As ecosystems recovered and prey animals grew larger, predators evolved to match them. The Triassic produced some of the most formidable carnivores in Earth's history, creatures that would dominate until dinosaurs finally displaced them. Erythrosuchus, living 240 to 230 million years ago, was an archosauriform reptile with a semi-erect posture. Its long legs, tall, narrow skull, and powerful jaws made it a fearsome predator. The largest species reached 16 feet in length with a skull over 3 feet long. Erythrosuchus was likely an ambush predator, using stealth rather than speed to capture prey. Its slow metabolism, typical of early reptiles, meant it required less food than similarly sized dinosaurs would later need. This efficiency allowed Erythrosuchus to thrive in environments where prey was scarce. Even more impressive was Postosuchus, one of the late Triasic's largest carnivorous reptiles. Reaching 16 feet in length and weighing up to 990 pounds, Postosuchus possessed a massive skull armed with dagger-like teeth. Bony osteoderms armored its back, providing protection during territorial disputes. Postosuchus was an ambush predator, lying in wait near water sources or game trails. When prey approached, it would explode from concealment, using its powerful jaws to deliver crushing bites. For millions of years, Postosuchus reigned as an apex predator across what is now North America. But environmental changes were coming. As the Triassic progressed, climates shifted toward more open, arid conditions. These environments favored the increasingly diverse and adaptable dinosaurs over the more specialized archosauriforms. Postosuchus declined, eventually vanishing as dinosaurs ascended to dominance. Giants of the Triassic. The Triassic period also witnessed the evolution of true giants, creatures whose size rivaled later dinosaurs. Lystrosaurus, discovered in Poland, represents one of the most astonishing finds in paleontology. This enormous herbivore lived over 200 million years ago, measuring nearly 15 feet long, 8.5 feet tall, and weighing 9 tons. Lystrosaurus was a Dicynodon, a group of mammal-like reptiles that survived the Permian extinction. Its fully upright stance and massive size challenged previous assumptions about Dicynodon capabilities. Lystrosaurus browsed on low and mid-level vegetation, using its beak to strip leaves and its grinding teeth to process tough plant material. It grew continuously throughout life, with the largest individuals representing the oldest survivors. This growth pattern differs markedly from modern mammals, which reach adult size relatively quickly. The existence of Lystrosaurus demonstrates that dinosaurs weren't the only large herbivores in the Triassic. Multiple lineages independently evolved gigantism, suggesting that environmental conditions favored large body size. Perhaps predation pressure, food distribution, or climate factors made being big advantageous. Plateosaurus, a late Triassic dinosaur from Central and Northern Europe, also achieved impressive sizes, ranging from 16 to 33 feet long and weighing 600 to 4,000 kilograms. Plateosaurus was among the first truly large dinosaurs. Its small skull, long neck, and plant-crushing teeth marked it as a dedicated herbivore. Strong hind limbs supported its weight, while grasping hands with claws could pull branches closer or be used for defense. Plateosaurus showed remarkable developmental plasticity, with individuals varying dramatically in size depending on environmental conditions during growth. Return to the seas. While reptiles conquered land and air, some lineages returned to the oceans their ancestors had left hundreds of millions of years earlier. Ichthyosaurs represent one of evolution's most dramatic transformations, land-dwelling reptiles that became fully aquatic predators. Appearing around 240 million years ago, shortly after the Permian extinction, Ichthyosaurs evolved with astonishing speed. Within a few million years, they had developed streamlined, dolphin-like bodies, powerful tails for propulsion, and limbs modified into steering flippers. Sizes varied dramatically, from 3-foot-long species to giants exceeding 60 feet. Some ichthyosaurs were toothless, possibly sucking in prey like modern baleen whales. Others possessed formidable teeth and likely hunted like modern sperm whales, diving deep to catch squid and fish. Evidence suggests ichthyosaurs were air-breathing and may have been warm-blooded, maintaining elevated body temperatures for enhanced performance. The largest ichthyosaurs appeared in the late Triassic, true giants that dominated oceanic food chains. Then, mysteriously, they vanished around 200 million years ago as the Triassic ended. The reasons remain unclear, perhaps environmental changes, competition from other marine reptiles, or simple bad luck. Other marine reptiles also thrived during the Triassic. Adopodentatus, with its bizarre hammerhead skull and specialized teeth, fed on underwater plants around 244 million years ago. Measuring 9 feet long, it was highly adapted for aquatic life and may have given birth to live young rather than laying eggs. The Triassic period ended 201 million years ago with another mass extinction, wiping out many of the creatures we've encountered tonight. But the survivors, dinosaurs, pterosaurs, crocodilians, and marine reptiles, would inherit the Jurassic world. The experiments of the Triassic laid foundations for 135 million more years of reptilian dominance. Every creature we've met tonight played a role in that story, testing evolutionary possibilities that would shape life on Earth forever. The age of dinosaurs had truly begun. Evolution's experiments in the Triassic set the stage for the dominance of reptiles across land, air, and sea. The age of dinosaurs had begun, and life on Earth would never be the same.